Alaikum. This is 11th chemistry, and our today's topic is covalent bond. We have, as dear students, we have already discussed this ionic bond or electrovalent bond. Now, today's topic is about this covalent bond. As you know that various theories have been put forth regarding this covalent bond. We have got Lewis Langmuir's theory, then we have got valence bond theory, we have got molecular orbital theory. So the first theory that was first of it was given by Lewis and Langmuir. They gave us they gave us the concept of this covalent bond. So I would say that it was Lewis in collaboration with Langmuir who introduced the concept of this covalent bond. According to them, a covalent bond is formed between two atoms by sharing of electrons. Now, depending upon the number of electrons shared, we have got a single covalent bond which is formed by sharing of one pair of electrons. Then we have got a double covalent bond which is formed by sharing of two pairs of electrons. Then we have got a triple covalent bond which is formed by sharing of three pairs of electrons. Now, after sharing of electrons, both the atoms participating in the formation of a covalent bond, they attain a stable configuration of the nearest zero group or nearest noble gas noble group elements. Now, as far as this covalent bond is formed, this bond is formed either between two similar atoms or between two different elements of comparable electronegativities. That means the difference between the electronegativity value of the two participating atoms, it should be very small, or in other words I would say that the two different atoms, in case the bond is formed between two different atoms, they should be of comparable electronegativities. So if we look at this covalent bond is mostly formed by the non metals in the periodic table, because these non metals, they have got a high value of this ionization enthalpy, and they do not easily lose the electrons, since the loss of electron in these non metals is rather difficult, because they have got a very high value of ionization energy. So they usually form molecules by sharing of electrons in order to attain the stable configuration. Now if we see in this covalent bond here, we see if the bond is formed between two similar atoms, then the resulting covalent bond or the resulting covalent bonded molecules, they are called as homoatomic molecules. Now, yeah, for example, we see here this H2 molecule, we have got Cl2 molecule, we have got oxygen O2 molecule, we have got N2 molecule. So they are all homoatomic molecules. Now, as far as this H2 molecule is formed, we see there is a single covalent bond existing between the two hydrogen atoms. Now, each hydrogen atom has got a single valence electron in its outermost shell. Now, in the formation of this covalent bond between the two hydrogen atoms, they approach each other, and this shared and they share each electron. This hydrogen atom shares the electron of this hydrogen atom, and this hydrogen atom shares the electron of this, and the shared electron pair, it lies in between the two hydrogen atoms, and it is utilized by both these hydrogen atoms in order to attain stable configuration. Or in case of this homoatomic molecules, the shared electron pair, it is equidistant from the two hydrogen atoms. Now, if this is the Lewis structure, that means if the shared electrons, or if we represent them by means of electron dots, then the structure is called as the resulting shear in this structures, they are called as Lewis dot structures. Now we can also represent this covalent bond by means of dashes. Instead of this electron dot structure, we can also represent this covalent bond by means of dashes or by means of lines. Then those structures, they are called as Cooper structures. Now in case of this, in the formation of Cl2 molecule, again there is a single covalent bond existing between the two chlorine atoms. Now the atomic number of this chlorine, as you know, it is has got a 17 atomic number, and it is electronic configuration is 287. Now if we look at its electronic configuration, we see there are 7 valence electrons in its octet, and same is the case with this chlorine and with this chlorine atom. So each chlorine is short of 1 electron, and these two chlorine atoms, they approach each other and share this electron to form a single covalent bond between the two chlorine atoms. Now after the formation of this covalent bond, or after the formation of this after the formation of after the sharing of this single electron, each chlorine atom has now, it attains a stable configuration. That means it has got now 8 valence electrons, and this chlorine has again got now 8 valence electrons, because the shared electron pair which is held in between the two, it is utilized by both these and these chlorine atoms in order to attain the configuration of the nearest zero group element, that is argon, which has got atomic number of 18. Now then if we, another homoatomic molecule is, that is oxygen diatomic molecule. We see in case of this oxygen atom, again we see that it has, this atomic number is 8, and it is electronic configuration is 2 6. So it has got 6 valence electrons in its outermost shell, and it is in need of 2 electrons. It completes its octet, this oxygen atom, by sharing the 2 electrons of other oxygen atom. So in this way a double covalent bond results. Now after double covalent, so in all we can say that two pairs of electrons are shared by these two oxygen atoms, and both oxygen atoms, after sharing these 2 pairs of electrons, they attain a stable configuration. Now each oxygen atom has got now 8 electrons into its outermost shell. Same is the case with this oxygen atom. So a double covalent bond results by sharing of 2 pairs of electrons. Then another example, homoatomic molecule, we have got a nitrogen molecule, in which there is a triple covalent bond between the two nitrogen atoms. Now if we look at the this configuration of this nitrogen atom, its atomic number is 7, and it has got its electronic configuration is 2 5. So 5 valence electrons are there in this nitrogen atom. Now this nitrogen atom is in need of 3 electrons to become stable. Now this nitrogen atom, it has also got these 5 valence electrons. The two nitrogen atoms, they approach each other and share these 3 pairs of electrons, and to give rise to the formation of 3 covalent bonds. See, in this case there are 2 electrons out of these 5 these valence electrons of this nitrogen atom. Only 3 electrons are involved in the formation of covalent bonds to form three covalent bonds. Now these 2 electrons which do not take part in chemical bonding, they are called as lone pairs, or we also call them as unshared electrons. Now the electrons which are involved in the formation of these 3 covalent bonds, they are called as bond pairs, or we also call them as shared pair of electrons. These are the homoatomic molecules, where we see how this covalent bond is formed between the two atoms. Now then, as far as the these heteroatomic molecules are concerned, where we see how this covalent bond is formed, the best example I will show here, it is here water. Now in case of
and in the formation of this water molecule, we see the ionization of energy is of hydrogen atom is very high, and similarly the ionization enthalpy of this oxygen is this oxygen atom is also very high. So the formation of this ionic bond here, it is not possible. So this hydrogen atom having a single valence electron, it shares this electron with the valence electron of this one valence electron of this oxygen atom. This hydrogen atom also shares it a single electron with the valence electron of this oxygen atom, thus giving rise to the formation of two covalent bonds. Here we see HOH, one covalent bond exists between oxygen and this hydrogen atom, and another covalent bond that exists between this between the oxygen and this hydrogen atom. So again we see here two bond pairs. Now two pairs of electrons in this case which do not take part in this bond formation, they are called, they serve as lone pairs. So in water molecule we have got two lone pairs of electrons and we have got two bond pairs. Then if you take the case of this methane, again here covalent bond formation takes place between the four hydrogen atoms and the carbon atom. Now carbon atom has um, got these four valence electrons, and it completes its octet by sharing four electrons from four hydrogen atoms to give rise to the formation of this methane. See here how the octet of a complete how the octet of this central carbon atom, it gets completed by sharing four electrons from four hydrogen atoms to form methane. Then in case of ethylene, there is a double covalent bond existing between the two carbon atoms, and that is which results from sharing of two pairs of electrons. Now here you see four hydrogen atoms are involved, and two carbon atoms are also involved in the formation of ethylene molecule. Now this carbon atom shares two of its electrons with the two electrons of this adjacent carbon atom. The other two valence electrons of this carbon atom, they are involved in the formation of bonds with the two hydrogen atoms to form two CH bonds on this carbon atom, and similarly two CH bonds are formed on this carbon atom, and a double covalent bond which is formed between the two carbon atoms from the sharing of by sharing of two pairs of electrons. So this is C double bond O, CH, 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 and CH. Then in case of ethylene, we see that there is a triple covalent bond which is formed by sharing of three pairs of electrons. Now the other electron on this carbon atom, it is shared with the electron of the hydrogen atom. Similarly the fourth electron on this carbon atom, it is shared with the with the electron of the hydrogen atom to form CH bond over here, and another CH bond over here. So CH triple bond CH. Then in the formation of ammonia, which has got a formula of NH3. Again we see the valence this shell of this nitrogen atom, it has got five electrons, and it is in need of three electrons to complete its octet. Now these three electrons, it shares with the three electrons from three hydrogen atoms to complete its octet. Now here in the formation of ammonium molecule, there are three shared electron pairs, or they are also called as bond pairs, and we have got a single lone pair of electrons on the central atom, that is nitrogen atom. So NH, 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 and this lone pair. Then you got phosphorus chloride or phosphorus trichloride. In the formation of phosphorus trichloride, three chlorine atoms are involved and one phosphorus atom is involved. Now again phosphorus has got five valence electrons, and it is in need of three electrons to complete its octet, and it gets its three these electrons from the from three chlorine atoms by sharing of it is these three electrons with the electrons of three chlorine atoms to form three covalent bonds. So that is P PCl PCl PCl, and there is again one lone pair of electrons on this phosphorus atom. Similarly, in case of this hydrogen cyanide, we see that it is a triatomic molecule. Again, all the three atoms are they are different: hydrogen, carbon, and nitrogen. Now hydrogen has got a single valence electron, carbon has got four valence electron, nitrogen has got these five valence electrons. Now this one of the four valence electrons of this carbon, it is involved in sharing of the electron of this hydrogen atom, and the three valence electrons, other three valence electrons of this carbon atom, they are involved in a sharing of the three valence electrons of the nitrogen atom to form a triple bond, resulting from the sharing of three pairs of electrons. So we have got HCN, and then we have got a triple bond between this carbon and nitrogen atom. Now then we have got molecular ions. We have got carbonate ion. Carbonate ion, again we see how this sharing of electrons takes place. This is a divalent anion. Now again we see this octet of uh, this oxygen atom, it is complete. Again the octet of this oxygen is complete, and octet of this is also complete, and carbon also complete, it is octet. Then we have got this sulfate ion. Now in sulfate ion, again we see that we see here that this oxygen, it completes it also completes this octet, and this also completes this octet, this also completes this octet. It has also got this now attains this valence, this has got now 8 electrons in its octet. So the resulting that is the molecular ion, that is sulfate ion. There are two double bonds, one between oxygen and the central atom, and another double bond between this oxygen and the central atom, that is sulfur. And we have got a single bond between sulfur and oxygen. Then now in all these cases we see that the octet or the central atom gets completed. So in most of the organic molecules we see that the central atom has got a stable configuration. That means its octet gets completed. But this octet rule, this is known as octet rule. That means when the atom has got 8 electrons in its outermost shell, in order to become stable, then the rule we call it as octet rule. Now as far as this octet rule is concerned, this octet rule, it cannot be applied, although it can be applied to a large number of covalent these molecules, particularly organic nature. However, there are certain exceptions to this rule, and that means in certain cases where we see that there are certain stable covalent molecules in which the central atom has got less than 8 electrons, and yet they are stable. So this is an exception to this rule. Again, in certain cases we see that the central atom has got more than 8 electrons, instead of 8. So and this that we call it, that is called as expanded octet of the central atom. See here, I will show you here. You see, just in this case we see that in case of incomplete octet of the central atom, now lithium chloride, in this case we see the octet of lithium, it doesn't get completed, yet it is stable. Then you have got beryllium chloride. Again we see the central atom, that is beryllium, it doesn't have got 8 electrons in its valence shell, and yet it is complete. And then you have got this BF3, boron trifluoride. Again the octet of the central atom, that is boron, it does not get completed, rather it has got only 6 now electrons in its outermost shell. And similarly, in case of aluminum chloride or aluminum trichloride, we see the octet of the central atom, it does not get completed, and these structures we call as Lewis structures. Now as far as the expanded octet rule is concerned, we see in case of PF5, phosphorus pentafluoride, the central atom, instead of 8, it has got 10 electrons in its outermost shell. And in case of this sulfur hexafluoride, we see that formula is SF6. Again, the central atom has got more than 8 electrons, rather it has got 2 rather there are 12 electrons in its outermost shell. Then you got IF IF7. This has got it has got 14 electrons. It has got 14 electrons in its outermost shell instead of these 8 electrons. But yet these molecules are stable. So this is an except. These are the exceptions to this octet rule. We have got incomplete octet of the central atom. Then you have got expanded octet of the central atom. But they are, although they are stable, quite stable, covalent, these molecules, but they do not follow the octet rule, in which, although it is this octet rule, it is observed in a majority of these covalent molecules. So this is for today. Inshallah, in our next topic we will discuss this valence bond theory. This is Lewis Langmuir theory, and it has got many limitations, and so it was then replaced by this VB theory. We will discuss it in our next topic. Thank you very much.